So polystyrene is an polymer. So the monomeric of polystyrene is propene, and it can resist for the high temperature and pressure too. And pressure. Okay, so let us know the structure now. So n number, if you are joining n number of propene, so that will gives you polystyrene. Okay, so here CH2, here CH, CH3, polystyrene structure. Okay, then sorry, this is not polystyrene, this is polypropylene. Oh, sorry. This is confused it. Polypropylene. It's not polystyrene, it's polypropylene. I'm extremely sorry. Polypropylene. Then polystyrene. So polystyrene, the monomeric is styrene. Polypropylene, propane. Polystyrene, styrene. And it is good thermal and electrical insulator. Good thermal and electrical insulator. So because of this property, we are going to use this polystyrene as a material for thermoflasks. So to maintain the hot and cold substances, so we are using it for household purpose and all things. So the structure of polystyrene, this is structure of styrene. So this is the structure of styrene. If you repeatedly add the styrene group, you will get polystyrene. Okay. Next, polyvinyl chloride, PVC. So the monomer of polyvinyl chloride is vinyl chloride. The monomer of polyvinyl chloride is vinyl chloride. So it's used for the manufacture production of raincoats and handbag, seat cover. Okay, so it is electrically insulated. It is electrically insulated. Then the structure of your vinyl chloride is like this. And if you're repeatedly adding the vinyl chloride, it will give you the structure of polyvinyl chloride. That will be this one. Okay, fine. So just make a chart that it will be really useful. Don't neglect my words. Just listening and receiving and sending out from one end to another end of your ears. Don't do like that. Please write and practice. And I don't know, while learning, will you have the concentration regarding what is the weightage of the lesson? Which question will be asking for this? Why you require that? During learning, don't divert your mindset here and there for marks and such things. And keep on saying this, you please learn, then that learning will always hold your hands. Don't think like this is important, this is not important. Don't. This is not the right time to uh, go through that points. So whenever you are come to the end of the point, I'll tell you each and everything. So it's just a learning point. You should learn and you should understand. Nothing more. Okay? Are you getting? So please try to understand, it is learning time. It's not a judgmental time. This one is important, this one is not. So you should read, you should not read. You should focus on this more. It's you can leave this. It's not that right time to judge your marks now. Read whatever, how much you possible. Learn everything. Okay? So if you are focusing on some things like that, oh, this is important, so this I no need to worry, this I need to worry. If it is like that, if you don't have that much of grip in the subject, so you lost your brain to listen in class, you lost your brain to understand the concept, you'll just run it behind your marks. But I don't want my students to be like that. I really hate such people. Seriously, I'm telling you, don't ask any marks, weightage of the lesson, what are the uh, what to say, updated syllabus for your academics. If it's available, then it's relief for us only. It will decrease our burden. We are only not bothering that. Why you are bothered? Ma'am, you are the lecturer, ma'am. We are the students, so we need to bother. Yes, of course, I know. But you have time for that. You have time. Hmm? No need to worry. Okay, cheer up. Come to the class now. So next, poly, poly, tetra, fluoro, ethene. While understand easily, while writing, explain it in a vast way. Okay. So poly, tetra, fluoro, ethene. So if you are seeing the words, the structure of those you should remember. Poly means many, tetra means 4 carbons are there, fluoro means fluoro group is there, ethene means double bond is present with CH2, CH2. So yes, now we came to the picture. So that you can call it as PTFE, or or Teflon. So usually listen this word called Teflon. Teflon cloths, Teflon material. So we usually use this word Teflon instead of polytetrafluoroethene. Okay. So the monomeric of this polytetrafluoroethene is tetrafluoroethene. See how simply you can made. Just remove the poly, so you will get the monomeric units. So no need to mug up in. Okay, so you can understand it simply. Tetrafluoroethene. So it can be resist for high pressure. Okay, can be resist for high pressure, and we are using this as an catalyst with the composition of persulfate. So this can be used as an catalyst with the composition of persulfate. Okay, fine. Let us know the structure now. So it's of NCFCl double bond. Okay, this is tetrafluoroethene. So now I have a question. Tetra means 4, ethene means two carbon. In this structure, have wrote fluoroethene. Where this tetra went? Where this tetra went? I have a doubt. If anyone know, please answer for me. Okay. Yes, Meghana. Fluorines. You mean to say four fluorines? Exactly. Exactly. So we have four fluorines, that is called tetrafluorine. Okay. So by this example, we came to know that not only for carbon, we can give the number as mono, di, tetra, tri for functional groups also. For functional group also. Or you can write 1, 2 difluorotetraethene. This is your IUPAC name. 1, 2 difluorotetraethene. This is your IUPAC name. IUPAC name. Okay. This is tetrafluoroethene. And when you are keep on adding your tetrafluorine TFE, so you will get poly tetrafluoroethene, that is called Teflon. This is called Teflon. Okay. Next, pan, polyacrylonitrile. Okay, polyacrylonitrile. Polyacrylonitrile, that is called PAN, pan. So the monomeric unit of pan is acrylonitrile. Acrylonitrile. So this acrylonitrile, when it's going to repeatedly add in the presence of peroxide, this act as a catalyst. We will get polyacrylonitrile, that is called PAN. So in the presence of catalyst called peroxide, we are converting the polyacrylate monomer into polymer as a polyacrylonitrile. Is it okay? Fine, next. Read the structure of acrylonite now. CH2 double bond CH and Cn. Okay, then polyacrylonite Cn. Okay. Fine. Next. Next one is polymethyl methacrylate. This is called PMMA, PAMA. Polymethyl methacrylate. Acrylate. It's obtained by the monomeric unit of methyl methacrylate. Methyl methacrylate. And this is the hard structure as usual, and this will be used for the making of the lenses. Okay, and transparent dooms, transparent dooms. Have you seen some classical models what they were made in hotels or some showrooms and all, with a doom colorful structure that is made up of polymethyl methacrylate. So, and because of the highly resistivity for the light, we are using this. Okay, so the structure of MA means polymethacrylate is N number of C double bond C CH3 COOCH3. This is called MMA, polymethacrylate. Then if you are going to add it continuously, you will get PAMA. Okay, fine. So this much you have in your additional polymerase structures. So what are we read from the first? It's a polythene, polypropene, polystyrene, polyvinyl chloride, polytetrafluoroethene, polyacrylonite, polymethyl methacrylonate. So this and all we have some important additional polymers. So now let us see some important condensation polymers. Some important condensation polymers. Okay. So first you have polyamide. Polyamides. So it's just a linking of the amide bond. Okay, it's a linking of your amide bond. So I'll write the amide structure. Please copy down C double bond O NH2. So this is called amide bond. So while writing the bond, you should write the bond of the left and right side. If the presence of atom is there or not, you should write. It's showing blur. Okay, next polyamides. This is the amine bond. So in that we have nylon 6,6. Nylon 6,6. This obtained from the condensation reaction. So the monomeric units, or I think you might have know this. So we already done with this. For the chart sake, we are going to write it now. Adipic acid and hexamethylene diamine. Okay, hexamethylene diamine. So this is having the resistivity of high temperature and pressure as usual. So this is the monomeric unit. This is adipic acid plus H2N. I think I have I've shown this how to write the structure by splitting and all. So no need to explain it again. You just write the structures and remember the structures. So it's very easy to write also and very easy to remember, because C the adipic acid COH and in between CH2 4 times. Same for your hexamethylene diamine. So it's NH2 and CH2 6 times. So what you will get, the product has nylon 66. So just remove H here and H here, same here. Remove OH from this two end and HH from this two end, then you can connect it. CH2 4 times. You just without seeing me, you just try to write it. NH, then CH2 6 times, then NH. So this is called plus n number of water molecule. This is your nylon 66. Okay, nylon 66. This is used as an making of bristles of brush. Bristles of brushes. You know that, right? Bristles, what we are used to brush. That is called bristles of brush. Next, second one, nylon 6. Nylon 6. So the monomeric unit of nylon 6 is your caprolactam. Caprolactam. So when you are heating this with water, when you are heating this caprolactam with your water, you will get nylon 6. So do you what the difference between nylon 66 and nylon 6? So we have the hexamethylene diamine in nylon 66. That's why hexa, because of this 6 group, we having putting 66. So this, so the monomeric unit is also different, and here also it's different. So when you are heating this caprolactam with water at the temperature of 533 Kelvin to 543 Kelvin, you will get nylon 6. You will get nylon 6. Let us write the structure. This is not hexagonal, this is hepta 7. Five 534 Kelvin. Then you will get this. This is double bond O, CH2, 5 NH. So this is called caprolactam. This is nylon 6. Okay. Fine. Finish. So if you have any interest regarding to see this structure, how it will made uh, caprolactam, how we can make this caprolactam, I can just show you the one simple resonanceal structure, how this we are making, because you don't have that, but for your knowledge sake, caprolactam, how we are making this caprolactam structure, I can show you that. So first, because it's heptagonal, right? So usually we'll get hexagonal. So how we can make that heptagonal from your hexagonal? So that is a cyclohexane undergoing oxidation. So we'll get like this. This is called cyclohexanone. ON is double bond of hexanone. And when you are reacting with the H2 NH2OH, your water source, so thus O is replaced by your NOH like this. This is called cyclohexanone ozone. So when it react with sulfuric acid H2SO4, you will get this one, NH C double bond O with the CH2, 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 1, 2, 3, 4, 5, 6. Sorry. 1, 2, 3, 4, 5, 6, 7, right? Okay, so this is for your sake. This is not asking in the examination. So this nylon 6 is used for the tire core. Okay, tire core, and for the ropes and fabrics. It's used in the this all kinds. Okay. Next, you have polyesters. So in that you have two more classifications. Then polyformaldehyde, then malamide, then that's it. Urea, yes, urea formaldehyde resins. Then copolymerization with rubber and um, vulcanization of rubber. So that is all you have. So that will be taken up in our Monday's class. Okay. Any doubt? Because session will end now. Any doubt you can